using this equation here for the decomposition of sodium azide, our question asks, if 85 grams of NaN3 sodium azide decomposes at 75 degrees Celsius and 2.3 atm, what volume of N2 will be made? Let's start by making a roadmap and talking about the steps that we're going to use to solve this equation. As I've said before, we ultimately want to put in a certain amount of sodium azide and then find out how much nitrogen gas we're going to get for that amount of sodium azide. But the only thing that we can plug into this equation are numbers in moles. And at the beginning of the problem, we're given an amount of sodium azide, but it's in grams. It's not in moles. So I can't put 85 grams of sodium azide right into the equation. So the first thing that I'm going to want to do, number one, is I'm going to want to take the grams of sodium azide and convert those to moles of sodium azide. Okay, there's my first step. Now, after I have the moles of sodium azide, I'll know how much of this I have. Then I'm going to want to be able to take that number and use it to find out how many moles of N2, how many moles of nitrogen gas I'm going to end up getting. So step 2 is going to be moles of NaN3, and use that to figure out how many moles of N2 I get. Okay, so then I find out how many moles of nitrogen come out of the equation. But I'm not done yet, because finally the question asks not how many moles of N2 I have, but what volume of N2 will be made. So step 3, the last thing that I need to do is I'm going to have to take the moles of nitrogen that I have and convert those to liters of nitrogen. So these are my 3 steps. Grams of sodium azide to moles of sodium azide, moles of sodium azide to moles of nitrogen, and finally moles of nitrogen to volume of nitrogen. So let's get started. The first thing that we have is we have 85.0 grams of sodium azide. How do I convert that into moles? Well, what I'm going to need to do is I'm going to need to use the molar mass, or the molecular weight, of sodium azide. And that here is 65 grams per mole. We get that by adding up the mass of sodium, because there's 1 sodium, plus 3 times the mass of nitrogen, because I have 3 nitrogens. I add this up and I get 65 grams per mole. Okay? So I can use this 65 grams per mole as a conversion factor. And there are actually 2 conversion factors that I can write. The one on the left and the one on the right. They're both perfectly fine. The question is, which of these do I want to use? Well, I'm starting out with 85.0 grams, and I want to be converting grams to moles. So I want to be using the conversion factor that is going to cancel out grams and is going to leave me with moles. We can cancel a unit out if it's on both the top and on the bottom. So the conversion factor I'm going to use is going to be this one, because grams are going to end up on the bottom. So I'll choose 1 mole divided by 65.0 grams, grams on top, grams on the bottom. So now I've got my grams, and they cancel out, and I'm left with moles. When I do this math, it's going to be 85 times 1 divided by 65. And the final answer that I'm going to get there, rounded to 3 significant figures, is 1.31 moles. We round to 3 significant figures because I have 3 digits there, 3 digits there, and the 1 is an exact number. It's in the definition, so we don't use this for the rounding. 1 mole, it's 1 mole. It's it's an infinite number of significant figures. Okay, so we end up with 1.31 moles of sodium azide, NaN3. So that's the first part of the problem. Now, we start with 1.31 moles of sodium azide. We want to find out how many moles of nitrogen gas we're going to get. Now we have to use the equation to set up a proportion. Let's take a look at the equation and see what is it telling us about the amount of sodium azide and the amount of nitrogen. This equation written like this, we have 2 here and a 3 here, essentially says this. It says 2 moles of NaN3 make 3 moles, see the 3 there, of N2. Okay? So I can express this statement, 2 moles of this to 3 moles of this, as a conversion factor. 2 moles of NaN3 to 3 moles of N2, or I can flip it the other way. Which of these am I going to want to use? Well, I'm going to start with 1.31 moles of NaN3. And I want to be able to multiply that by the conversion factor that's going to get rid of NaN3, and it's going to leave me with moles of N2, so I can find out how many moles of N2 I get after that goes through this equation. So I can use this one, I can use this one. I'm going to use this conversion factor because NaN3 is on the bottom, so it'll cancel out this. It's on top. So 3 moles N2 divided by 2 moles of NaN3. Now I have sodium azide on the top, sodium azide on the bottom. They cancel out. And the math I'm going to do is 1.31 times 3, and then the answer to that, divided by 2. And when I do that, round it to 3 significant figures, because 3 and 2 are both exact numbers that have an infinite number of significant figures, I get 1.97 moles of N2. Okay? So that's the answer to the second part of my problem. 1.97 moles of N2. Okay? I'm 2/3 of the way there. Now, the last thing that I need to do, because I'm asked for the volume of N2, not the number of moles, is to take the moles of N2 and find out the liters of N2. Now, this is a gas, so you might be thinking, aha, it's very easy to take the number of moles of the gas and convert it to liters, because you may say 1 mole of any gas takes up 22.4 liters of volume, so we can just multiply this by 22.4, right? No, we can't do that. Why? Because 1 mole of a gas takes up 22.4 liters only at STP, which is 0 degrees Celsius and 1 ATM. Am I at STP here? No. I'm at 65 degrees Celsius, not 0 degrees Celsius, and I'm at 2.3 ATM, not 1 ATM. So I cannot use this rule because I'm not at STP. Because I can't use this 22.4 liter rule, instead, I'm going to have to use the ideal gas law, PV equals nRT, which lets me calculate the volume of a gas sample under any conditions, not just under STP. So what I'm going to want to do with this is I'm going to take my ideal gas law and I'm going to plug the various variables into it. I put my pressure in here, I have my moles, 1.97 moles of nitrogen. I have to take the temperature, which is in Celsius, and then add 273 to it to get the Kelvin temperature. And finally here is the R value, the constant that I'm going to be using. V, the volume of this gas, is what I'm going to be solving for. And just to mention it one more time, I have to use the ideal gas law to find the volume because I know the number of moles of N2, but it's not at STP. So if it's not at STP, you have to use the ideal gas law to find out what the volume is. Okay? So I've got my variables here, and I don't want to have to bore you with the math, so I've already gone through and set up and solved the problem right here. Okay? So PV equals nRT, multiply both sides, divide both sides by P, cancel that out, V, and then I plug everything into this equation. I leave R till the end. If you have any questions about how to set up and solve the ideal gas law, I have a whole bunch of videos on those that should help. So now, we go through, we cancel the units. Moles up here, moles down there. Kelvin up here, Kelvin down there. ATM down here, ATM up there, and I'm left with liters, which makes sense because that's what I want to do. I want to solve for volume. So, I do this math. 1.97 times 384 times 0.0821, all of that divided by 2.3 ATM. And the answer that I get, rounded to 3 significant figures, 3, 3, 3, and 3, is going to be 24.5 liters. And that, for my step 3 here, 24.5 0.5 liters is my final answer for the volume of N2 that will be made through this equation. So just once again, we started with the grams, went to moles, then moles of sodium azide to moles of nitrogen, and then because it wasn't at STP, we had to use the ideal gas law to find out how many liters that number of moles would take up at these conditions here. Now, this was one example of a gas stoichiometry problem. But when you're doing these yourself, you're never going to get the exact same problem that I've done here. So instead, I want you to think about the steps that I take and figure out how you can apply those steps to the problems that you're solving. You might have to use the ideal gas law to go from moles to volume, or from volume to moles if it's not at STP. And you're probably always going to have to convert from liters or from grams into moles, and then go from moles to moles in an equation like this. So again, I want you to think about the steps that I go through and try to figure out how you could use these in the problems that you have to solve. Don't just try to copy exactly what I do, because it's not going to help, but think about how I work through it with a roadmap and the choices that I have to make, and hopefully you can apply those to what you have to do on your own, and it should all work out. Good luck.